sixth chapter on number. In this chapter, I will talk about the factors, and on the basis of that concept, I will describe some of the related topics which will be useful. Okay, so let me start with the topic factor. So, if I define factor, then is the number which is a factor to any number if that is a perfect divisor of the given number. So, is the number which is a factor to any number if that number is perfect divisor of the given number. So let's say a number given is b. Now we have to prove whether a is perfect divisor, is a factor of b or not. So in that case, if I divide b by a, that means b is the given number whose factor a has to be proved. Now if I take b by a, means if I divide b by a, then it has to be an integer. If it is an integer, then we can say a is a factor to b. Understand? So the definition says the same thing. If I say that any number is a factor to any other number, then it can be proved only if the number which has to be proved as a factor, you have to divide the other number by this number and you have to get a integer, not any decimal, non-negative fraction. So this is the rule. So if I take the practical example, if I say whether 2 and 3 is factor of 6. I am taking a simple example, smaller example, so that it could give you a perfect concept. So what I have to do, I have to divide 6 by 2, it will come 3. If I divide 6 by 3, it will give me 2. So these are integers, so that means 2 and 3 are the factors of 6, can be said. So this is the concept of factors. So on the basis of this factor, the things that can be said, some topics can be taught on the basis of this concept. Those topics are HCF, or in other way it can say GCD. HCF is highest common factor, okay, or that GCD means greatest common divisor. Okay, any of these two will say the same thing, or will give you the same result. So if I say the highest common factor, that means this common things only will come when we compare two numbers. That you can understand from this term. Highest means out of the common you have to take the highest one or the greatest one, and factor means we already told that factor means the highest common, means the highest number that I will choose has to be a factor of those number together, because it is a common. So the number which I will take has to be a perfect divisor of those two numbers, or it should be a perfect divisor. This factor and divisor are the alternative terms. So factor, if I say, so it has to be a perfect divisor also. So if I take any small example, 6 and 12, so from there 6, the factors are 2, 3, 6 itself and 1. For 12 it is 2, another 2 will come, 3 will come, 6 will come, 12 will come, 1 will come, and 4 will come. So these are the factors. These are probable factors. 2 can be a divisor, 3 can be a divisor, 6 can be divisor, 1 can be divisor of 6. Similarly, 2 can be divisor. So I will not repeat it again. So I will say one time. So 2 is a divisor, 3 is a perfect divisor, 6 is a perfect divisor, 12 is a perfect divisor, 1 is also, and 4 is also a divisor of 12. So out of these, which are common but the highest one? So 12 is, although it's the highest, but it is not common every time. Whereas the next one is 6. Out of this all numbers, 6 is the next highest, but 6 is common in both. So I have to pick this 6. Now see, if 6 I pick, 6 has to be a perfect divisor or factor of both. So 6 is definitely a factor of this, and 6 is definitely a factor of this. So for this case, my solution would be 6 for the highest common factor, or GCD, would be 6. I think the concept is clear to you. Okay. Now next comes the topic which is depending on the basis of this factor is the term LCM. That means lowest common multiplier. So in this case, you can see it is just opposite to the earlier one. Here I need to have common, this is there, but the lowest. At that case it was highest, and it is lowest, and multiplier. That means I would get something which should be the number that I will get from that two numbers. So this number, whatever I will choose, the common one, that this case is a perfect dividend, not the divisor. This number what I will choose will be perfect dividend to those numbers. Once by these two numbers, it could be perfectly divided. That means these two numbers which will be given for calculating this LCM has to be a perfect divisor or factor to the number I will choose. So if I take the same example, 6 and 12, in this case, if I have to choose something which will be a perfect dividend, that means the number must be more than this. Otherwise, I cannot divide something which is less than this and common to that. So out of these two things, if I take the multiple of 6 is starting from 6, 12, then 18, 24, like that, it will jump 6 times every time. If I take the same thing, it will start from 12, then after 24, then after 36, so like that. So in this series, anywhere some number will match. Means if I go further, so this will see 30, 36. Now I see here 12 also matching. These are common. I need to have common multiplier. That means multiplier for this means it could be some multiple of these two, but that has to be common, and I need to choose the lowest out of that. So where it is 12 is matching, then after 24 is matching, then 36 also matching, but I need to choose the lowest one, because 12 is the lowest, and below that I am not getting any common which will be a perfect multiplier for both these numbers. So for this case, I have my answer would be 12. So this is the meaning of lowest common multiplier for any number. Okay, so I think you have understood the thing. Now there are methods by which we can calculate or you can solve the problem where you are told to find the HCF or LCM. So first come the HCF or GCD, whatever it is. So in this case, the problem can be sorted out with the method of factorization. Factorization is nothing but calculating the factors of the number, or the second is division method. Okay, so one by one I will show. I will take the same example. Now earlier I have shown that if it is factorized, then it would come 2, 3. The factors are this one 2, 3 for 6, and for 12 it is 2, 3, 4, 6, 12 and 1. So after this I will choose the highest common out, because this is also common, highest common of this number, which will be your answer. So this is the method of doing factorization. So factorization generally we do the prime factorization. The term called is the prime factorization. Well, the prime factorization is prime factorization means I have to divide the given number with starting from the smallest prime number till I will get 1. So the definition says prime factorization is that we have to divide starting from minimum prime number till we get 1. So this is the definition. If I do factorization of any number, that means you have to start dividing that number with a minimum prime number. The minimum prime number is 2. From there you have to try that number to be divided. So starting from 2 till I get 1 as a answer, I have to divide that number consecutively and repetitively. Means these two terms will come consecutively and repetitively, or you can say or repetitively. So if I do continuous or consecutive division starting from the minimum prime number till I get 1, that will be the prime factorization. Now let me give you some example where how it happened. Let's say 24. So I will mark it like that with this symbol, and I will start doing factorization with the minimum prime number if it is possible, I am saying. Then otherwise the next prime number you have to choose. So first with 2 I will try. So 24 is divisible, so the result will come 12. Then after I will try again with the minimum. If it is okay, then otherwise I have to go the second. So 6, then 2. Now see, this is again not divisible by 2 as because it is odd number. So I will try with the next prime number till I get 1. So whenever I will get 1, I will to stop it here. So the factors of 24, I could say 2 into 2 into means 24. How will I get? 3 into 1. So now see, these are the numbers by which I will get 24. But you see, with these numbers I can make any two numbers which will give you the 24. So 24 can be fetched from 2 into 12, so that I get from 2 1 and other things together, or otherwise 4 into 6, same thing I get it from here. The reverse of this also possible, but I will show you the one kind. And here 2 and 6 and 12. The next is 6 into 4, the other, if I reverse it, 12 and 3 into 8. So these are the thing is possible, otherwise the opposite also. So in this case, every time I will get 2 factor together to get 24. So all total I will get how many factors? 1, 2, 4, 6, 8. So these are the, but in case of perfect square I will get 1 less. So this is the factorization, prime factorization, and from prime factorization factors I can create a pair of numbers which will give you the number itself. So this is the process of doing factorization, and from that I can calculate HCF. But if I want to do with the help of division method, so what I have to do in this case, I have to divide the higher number with the smaller number. So 6 2s are 12. Now here I am not getting anything at the as a reminder. So if I am not getting, so this will be finished, and the dividend will be the answer. So remember, if two numbers is given and you are being asked to calculate the HCF, in this case I have to divide the bigger number with the smaller number, and the last dividend whatever I will get will be the answer. So let me give you some more means example. I will take 12 and 18. Okay, now as per the rules I have to divide the higher number with the smaller number. So this will divide for 1, so quotient will be 1, and if 12 will come, 6 I will get as a remainder. So next this remainder will divide this number, the smaller number, out of this which is given for calculating HCF. So whatever was the remainder, from with that remainder I will divide the smaller number to try to divide it. So 6 to 12. Now if this ends here, then whatever the last dividend I will get will be the answer for this, the HCF. HCF would be 6. So this is the method of division by which I can get HCF. So if I take something which can be a prolonged one, so that would clear you much. So I will take something, let's say 6, and it is not perfect divisible, 64 I am taking. So let's check it. So 6, so it will come something 616, 4 will come, that means 0 I have to take. So 4 I will divide 6. So what would come? 4 ones are 4. It will not end up here. 2 will be remainder. Then with the 2 I will again do 4. So 2 2s are 4. So here you can see 4 4. So there will be no remainder. So the last dividend I will get will be the answer for this, that HCF. I think now you have understood till it finishes off where that your remainder comes 0, and the dividend in that case will be the answer. The last dividend will be the answer. Sorry, I am saying this is divisor, not the division. Sorry, I am mistaken. Till now whatever I have said dividend, you just take it as divisor. The last divisor will give you the answer. Okay. So this is the method by which I can calculate HCF. So this is case of HCF. Now if I want to calculate LCM, that is not possible with the division, because division means you are diminishing something, whereas LCM is a multiplication. So you will not able to reach by division method the result of LCM. And one another method by which you can calculate both, means LCF and LCM you can calculate both, in case if we try. So let's check with the 6 and 12, the smaller one. So what I have to do, I have to do the factorization with the common numbers. Okay, so I will start with the minimum prime number 2. So starting with 2, if I go, so it will give you 3, 6 here. Then further with 3, I will get 1 and 2. So further it will be stopped here, and HCF in this case will be the factors. When I take the left hand side factors and multiply it together, it will give you the HCF, and the LCM of for this case I will get by multiplying all such factors I am getting. That means 2 into 3 into 1 into 2. In this case, this is 6 and this is 12. So further going to the explanation of this, I want to give you the exact method and the limitation for this case, where I can calculate the HCF and LCM together. So prior to give you any other example, let me explain the limitation. This has a limitation, and that limitation is it can only be done for 2 digit, for not 2 digit, for 2 numbers together. That means if the number for which HCF and LCM has to be calculated, that must be 2 numbers only, not more than 2 numbers. So for more than 2 numbers means 3 numbers and above, we cannot follow this rule. So this is the limitation, and the exact methodology for this. When I am doing this, I have to take some factors which is common to both. So keep it in mind, not prime, not low. Rather, you keep in mind that I should take a number which is common to this both. Till I am getting that common factor, I will do divisions. Once I get co-prime, then I have to stop there. So that means why I am initially said start with a minimum prime number, so that it will ease your calculation. If you are good in calculation, so I can straightaway can take the factor, the biggest factor. Otherwise, to limit the number of steps, I can take 6 directly, which would be a common factor for this number, and it will give you this. Now this number doesn't have any common factor. Why I am saying till I get the cofactor here? That means cofactor are those, co-prime are those, co-prime are those which have only one as common factor. Simply in this language I can say co-prime are those which have only one as common factor, means there is a common factor that is only one. So till I get any such combination, I will go on dividing those numbers. So let me take another example where it would clear you much. If I take any bigger number 24 and 72, let's say, and I go with that, initially it is very difficult to find instantly to the biggest factors. Rather, that's why I'm saying start with the minimum prime, so that it will ease your calculation. Otherwise, if you are good in a calculation, then you can take some bigger number and you can reduce your steps. Okay, both is okay. So 2, then it is 36. If I take 2, then again it is 6, 18. 2 again, 3, 9. See, these are having some common factor 3, 1 and 3. Now, if I find here, it has no other common factor other than 1. So I will restrict my calculation, and in this case, this if I multiply all these factors will give you HCF, and if you multiply this further, it will give you LCM. So this is the rule. Let me take another example where apart from 1 will come as a last value of this. So if I take 24 and 81 say, so here 2 won't come as a common factor. Rather, if I take 3, 38 and 327. So you can see after that these are not having common factor. So you can say I will end up here and I will get 3 as a HCF for this, and if you multiply all this will give you LCM. Okay, so you have to stop here. You need not to calculate further as because there is no common factor further this. But the limitation is that you cannot go beyond 2 numbers. That means I cannot definitely say that it will work for this. It may or may not work. Okay, let me try with this. If I go 2, 3, 4. Now as per rule, as because these are having no common factor, I have to stop here. So that means 2 is HCF. So it is satisfying for this case. And 2 to the 4, 4, 3, 2 to the 4, 4, 3, 12, 12 into 4, 48. But in this case, LCM doesn't satisfy because if I take 4 series, it is 4, 8, 12, 16, then 20, 24. Whereas in 6, 12, 18, 24. In 8, it is 8, 16 and 24. So that means the lowest multiple is 24, but as per the calculation is coming 48. So we cannot define that for 3 numbers the rule will act or work. So it is only limited for 2 numbers. Further, another method where I can find the HCF, this says if the difference of two numbers given is a perfect divisor of the numbers, then the difference is the HCF of those numbers. So what it says, let's say there is 2 numbers A and B given, you have to find the HCF. Okay, now if we find A, and here condition is A greater than B, I am assuming, so A minus B, whatever be the result, if this will be a perfect divisor, that means A minus B by AB is an integer, or B by A minus B is an integer, then I can say that A minus B is the HCF. So if this has to be true, then I have to give in some example where you will find this also lies good for any numbers. So let me check with one pair of number. Let's say I am taking 64 and let's say 85. Okay, now I need to have some numbers which is perfectly divisible, means have perfect common factors. So if I take something, let's say 64 and 85 won't give multiple, then let's say 63 and your 84, let's say. So the difference of this is 21. Now 63 upon 21, if I say, it is 3, and that of 84 upon 21, it is 4. So that means 21, the difference of this number which is there, it is a perfect divisor for these numbers. So I can say 21 is the HCF of that number. Okay, so this is one example. I will come with more number of example and some more facts in the next video. Now for now it is okay, and I am ending this chapter. I will come on the next chapter with a more example. Thank you.